Hi everybody, it's Steve Knight with another Consensus Medical Systems Blood Flow Minute. If you're not on the listserv UVM FlowNet, you've been missing a great discussion about dialysis access evaluations with duplex ultrasound. There seems to be a general lack of consensus on how to correctly perform volume flow measurements, where to take the measurements, and what the results suggest. There have been several definitive papers on dialysis access surveillance, and I will include a few of the references in my written comments. I have collated from these articles 10 of the key things that I think we should keep in mind when performing volume flow measurements. Number 1, activate mean velocity autotrace. This is the easiest part of the exam. Number 2, deactivate peak velocity autotrace. Some ultrasound machines will try to use this information to calculate volume flow. Just eliminate the risk. Number 3, turn off the color. Number 4, first measure the volume flow in the feeding artery. The preferred site is the distal feeding artery, 2 to 3 centimeters proximal to the anastomosis. It's estimated that more than 90% of the brachial artery flow is destined for the dialysis access. This makes it a suitable surrogate for estimating volume flow for the access. Number 5, carefully select any site of the measurement. Find the straightest, most uniform segment with parallel walls, no stenosis, and only mild to moderate spectral broadening. Number 6, open the sample gate to span the entire vessel wall. Failing to do this will eliminate the lower velocity blood flowing along the walls, which will skew the mean velocity value upward. Number 7, zoom in on the B-mode image so diameter measurements are more accurate. That tip is mine, but I'm an old codger with failing eyesight. Number 8, set the angle correction at 60 degrees. Number 9, manipulate the beam or the transducer without compressing the vessel so that the angle correction cursor is parallel to the posterior wall. This is perhaps the most difficult part of the whole process and may require a lot of gel. B-mode inclination should be perpendicular to the lumen of the vessel being measured to give the best resolution of the intima. Measure inner to inner. And number 10, trace the waveforms for a minimum of 3 cardiac cycles, but the more the merrier. When measuring the diameter, measurement cursors must be placed at the same location as the Doppler sample volume. This is critical because any error in measurement will be amplified by the square of its value. And this is why color shouldn't be used. It will obscure the precise border of the intima. When measuring the volume flow on the venous side of the fistula, where the velocities tend to be very high and flow is chaotic, it's important to find a good location. Chaotic flow will appear below the Doppler baseline and skew the mean velocity value. You may need to find a site downstream, that is to say more central, where velocities decrease and flow becomes more organized. Avoid a tortuosity or other flow disruptor. Look at the waveforms. Does the mean velocity tracing emulate the velocity profile, or is it jagged, or does it drop down to the baseline in spots? All these manifestations will throw off the calculation. You should make at least 3 measurements at each location and the results should be similar. I aim to be within 100 milliliters per minute of the other values. Discard any significant outliers before averaging. When all is said and done, does the value make sense? Remember that the human heart puts out less than 5 liters per minute at rest. If you're getting a value like 4,000 or 5,000 milliliters per minute, then check your technique and or your machine settings. It's imperative that the machine is set to use the temporal average mean velocity and not the peak mean velocity. How many errors can you spot in this image? This poor devil has a volume flow 4 or 5 times the total cardiac output. Dialysis access creates an abnormal hemodynamic system due to the steep pressure gradient from the arterial to the venous side of our circulation without the hydraulic dampening of a capillary bed in between. Expect high velocities and disturbed or turbulent flow proximally and at bends and decreases in diameter. Volume flow is complex and it relies on several assumptions. Is it perfect? No, but it's reproducible and comparable over time when done correctly and consistently. This has been another Consensus Medical Systems Blood Flow Minute.